Welcome back after your well-earned break. It's quiz time now, and I'd like to introduce Dr. Anna Ploszajski, who's made a fantastic winter material science themed quiz. Anna.
Well, thanks so much for joining me for this Christmas quiz, everyone. This is very exciting. And there's going to be 12 questions coming up. So if you have a pen and some paper handy, then you'll need to write down the answers to the winter materials quiz questions. So yeah, get yourself a pen and a piece of paper, and I'll start the quiz shortly. Okay, so hopefully everyone is all set. This is the winter materials quiz. There's going to be 12 questions, all on different aspects of materials in the wintertime. So without further ado, here goes. Question 1. What is the coldest possible temperature in the universe? Is it A, universal 0? Is it B, minus 273 degrees Kelvin? Is it C, absolute 0? Or is it D, 0 degrees Celsius? So the question is, what is the coldest possible temperature in the universe? Okay.
Hi, Anne. I'm really sorry to interrupt, but we actually can't see the slide with the question written on it.
Oh, that's strange. It says on my screen sharing is paused. Does somebody need to give me permission?
So we can see your PowerPoint in edit mode. We just can't see the presentation.
Oh. Okay, 1 second. Thanks for letting me know.
That's okay.
How's this?
Yeah, it looks good now. Thank you.
Perfect. Thank you so much for pointing that out. Okay, so hopefully that all made sense. Is it A, universal 0? Is it B, minus 273 degrees Kelvin? Is it C, absolute 0? Or is it D, 0 degrees Celsius? Okay, question 2. The coldest temperature ever recorded at ground level on Earth is minus 89.2 degrees Celsius, measured at the Soviet Vostok Station in Antarctica on the 21st of July, 1983. The question is, why couldn't they measure this temperature with a standard mercury thermometer? Is it A, because mercury thermometers hadn't been invented yet? Is it B, that the mercury was frozen? Is it C, that the thermometer was buried under too much snow? Or is it D, that it was too dangerous for them to go outside and measure the temperature by eye? So the question is, why couldn't they measure minus 89.2 degrees Celsius with a standard mercury thermometer? Okay, more snowy questions coming up. Question 3. Snowflakes are famously said to have 6 sides, But what is the origin of this six-sided symmetry? Is it A, the formation of water molecules as they freeze? Is it B, probability? Is it C, the very cold atmospheric temperatures? Or D, that all the other shapes melt before they hit the ground? So why do snowflakes famously have six sides? Question 4. In order not to slip on the ice, it's important to wear grippy shoes. Put these materials in order of their coefficient of friction on ice, from lowest to highest. So in other words, from most slippery to least slippery. And the materials are steel, wood, brass, and rubber. So put these materials in order from the most slippery to the least slippery. Steel, wood, brass, and rubber. Okay, question 5. Temperature is the measure of the average what kind of energy of the moving particles in a material. Is it A, potential energy, B, chemical energy, C, heat energy, or D, kinetic energy? So when we measure the temperature of a material, what kind of energy is it that we're measuring of the moving particles in that material? Potential, chemical, heat, or kinetic energy? Question 6. While rummaging around in your freezer for some ice cream this winter, something I'm going to be doing a lot, you come across 4 strange objects. On closer inspection, they're made of 4 different materials: copper, glass, ice, and stone. When you pick them up, which one feels the coldest? Would it be copper, glass, ice, or stone? Okay, question 7. If you're wanting to choose an energy-saving winter light decoration, what sort of lights should you choose? Should you choose LEDs, incandescent bulbs, candles, or oil lamps? If you're wanting to choose the most energy-saving winter light decoration, what sort of lights should you use? LEDs, incandescent bulbs, candles, or oil lamps? Question 8. You have a light display in your house made up of green, red, and blue LED lights. Put these in order of wavelength from lowest to highest. So put green, red, and blue in order of wavelength from lowest to highest. Question 9. You go on a wintry walk and find some pine cones lying on the ground. You want to make these into a festive wreath, but unfortunately they're all closed up. How can you get the pine cones to open out? Can you use a knife to prise them apart? Place them on a radiator? Soak them in the sink? Or just ask them nicely? So you come across some pine cones and you want to make them into a festive wreath, but the spines on the pine cone are all closed up against the cone. How do you get those pine cones to open out? Do you use a knife, place them on a radiator, soak them in the sink, or just ask them nicely? Question 10. What wintry decoration was once made from tungsten and is now more likely to be made from Indian gallium nitride, gallium indium phosphide, or aluminium gallium arsenide? Is it tinsel, fairy lights, battery-powered robot figurines, or brightly coloured jumpers? What wintry decoration was once made from tungsten and is now more likely to be made from indium gallium nitride, aluminium gallium indium phosphide, or aluminium gallium arsenide? Tinsel, fairy lights, battery-powered robot figurines, or brightly coloured jumpers? Question 11. Candles are a popular winter decoration, but what force of physics causes melted wax to travel up the wick? Is it gravitational forces, pressure, capillary forces, or heat differentials? So why does melted wax travel up the wick? What's the force of physics that causes that effect? Is it gravitational forces, pressure, capillary forces, or heat differentials? And finally, question 12. Fireworks are popular over the wintertime. How is the colour blue produced in fireworks? Is it sodium compounds, strontium compounds, copper compounds, or aluminium compounds? How is the colour blue produced in fireworks? Is it sodium compounds, strontium compounds, copper compounds, or aluminium compounds? Okay, the next slide is actually a bonus question. So the quiz is out of 12, but question 13 is a bonus question. And I'm going to give you 30 seconds, according to my watch, to name as many materials as you can in this festive scene, starting from now. Stop. Okay, that's the end of the quiz. So swap your answer sheets with whoever you're sitting nearby with and get ready to mark the quiz. So here are the answers coming up. So question 1 was, what is the coldest possible temperature in the universe? Universal 0, minus 273, absolute 0, or 0 degrees Celsius. Now, the answer to this is, of course, absolute 0. You could also have had minus 273 degrees Celsius or 0 Kelvin, but you had to pay attention to those units on there. Question 2. The coldest temperature ever recorded at ground level on Earth is minus 89.2 degrees Celsius, measured at the Soviet Vostok station in Antarctica on the 21st of July, 1983. Why couldn't they measure this temperature with a standard mercury thermometer? The answer is that the mercury would have been frozen at that temperature because mercury is normally a liquid at room temperature, but it actually freezes at around minus 40 degrees Celsius. So at minus 90 degrees, it certainly would have been frozen. So well done if you put B for that one. Question 3. Snowflakes are famously said to have 6 sides. What's the origin of this 6-sided symmetry? The answer is A, the formation of water molecules as they freeze. When water freezes, it freezes in this sort of hexagonal arrangement of water molecules as they add on to each other. And ice is what we call a crystalline material. So all of the molecules in there line up in a very rigid structure, which is predictable and has this beautiful symmetry. And the result of that is that when snowflakes fall through the atmosphere, they follow this hexagonal symmetry to create hexagonal patterns with 6-sided symmetry. Question 4, all about coefficients of friction. So if you don't want to slip on the ice, it's important to wear shoes with lots of grip. The question was to put these materials in order of their coefficient of friction on ice, from the lowest to the highest. In other words, the most slippery to the least slippery. So the most slippery material here is brass. This is a metal that has a very low coefficient of friction on its surface. And the reason that your coat zip might be made of brass or house keys are made of brass is exactly for this reason, because its surface is very slippery and can slide over mechanical gears really easily. Next, we have steel, which if it's very smooth can have quite a slippery surface. Then wood, because it's generally quite sort of granular and rough, that increases the coefficient of friction. And then rubber, of course, is what we make all of the soles of our shoes out of today. And that's exactly for this reason, because it has a coefficient of friction on ice that will stop us from hopefully slipping around. Question 5 was all about temperature and the physical meaning of temperature. So when we measure temperature as material scientists, what we're doing is we're measuring a type of energy in the molecules and atoms of that material. And that type of energy is kinetic energy. So well done if you put D for that. When those particles are moving and vibrating in that material, they have kinetic energy. And it's that we're measuring when we measure temperature, which is kind of weird to think about because normally we think of temperature as heat, but it is actually kinetic energy. Okay, question 6. While rummaging around in your freezer for some ice cream this winter, you come across 4 strange objects. On closer inspection, they're made of 4 different materials: copper, glass, ice, and stone. When you pick them up, which one feels coldest? Well, so this is really a question about the extent to which materials draw heat away from your skin. In other words, their thermal conductivity. Now, because all these materials are in a freezer, they should all be at the same temperature. So it's not a question about which one is coldest, but it's a question about which one is going to draw the heat away from your skin most effectively. And the answer is copper. Copper has a really, really brilliant way of drawing heat away from your skin, a very high thermal conductivity. So well done if you put copper for that one. Okay, question 7. If you're wanting to choose an energy-saving winter light decoration, what sort of lights should you choose? So this is really a question about the energy usage of different lights. And of course, the answer is LEDs. These are very, very low energy light bulbs. Incandescent bulbs use a lot more energy. Candles don't use a huge amount of energy, but oil lamps are the most energy hungry of all. So the correct answer here is LEDs. And on that note, if you have your low energy light display in your house made of green, red, and blue LEDs, then put these in order of wavelength from lowest wavelength to highest wavelength. So the answer here is blue, green, and red. So blue is a color with a very short wavelength. And as we go through the rainbow of colors, the wavelengths get longer and longer. So then it's green and then it's red. Question 9. You go on a wintry walk and find some pine cones lying on the ground. You want to make these into a festive wreath, but they are all closed up. How can you get the pine cones to open out? Now, the answer here is to place them on a radiator, because pine cones are an amazing example of a smart material. So these are materials that move in response to the external environment. So in the case of a pine cone, when the pine cones get wet, the spines on the pine cone close up, and they do that because of a really clever arrangement of wood in all of those little spines on a pine cone. One of the sides, when it gets wet, will swell more than the other side. So when one side swells, it causes the whole pine cone to close up around itself. And it does that when it gets wet, as I said. So if you want it to open out and do the reverse of that effect, then you want to dry that wood out as much as possible. And from this list, the way to dry out that pine cone would be to place it on a radiator. Question 10. What wintry decoration was once made from tungsten and is now more likely to be made from all of these other materials with very long names? Is it A, tinsel, B, fairy lights, C, battery-powered robot figurines, or D, brightly coloured jumpers? Well, the answer is fairy lights, because these long and complicated compounds that I mentioned are all semiconductors, and we use different layers of these semiconductors in different arrangements to be able to make LEDs, or light-emitting diodes. On the other hand, tungsten is what the filaments of the old type of incandescent bulbs are made out of. So we no longer use tungsten, and we now use these types of semiconductors to light our festive displays. Question 11. This was all about candles and asking what force of physics causes the melted candle wax to travel up the wick. And the answer is capillary forces. So these are kind of amazing forces of physics that allow liquids to travel against gravity if it's going through a very thin tube called a capillary. So the construction of the wick of the candle is made up of lots of different strands of like a cotton thread. And all of those together form very thin channels through the wick, by which way the hot wax is able to travel up and then burn in the candle. Okay, question 12. This was about the fireworks. How is the color blue produced in fireworks? The answer is copper compounds. This was quite a hard question, but it's copper that is responsible for that lovely blue color when fireworks go off. So very, very well done if you managed to get that one right. And the final bonus question, you can give yourselves a mark out of 12 for questions 1 to 12. And the final bonus question doesn't count towards the marks, but it's just a fun way of taking notice of the materials around us. And these are all the materials that I managed to get. You may have come up with many more. So well done if you got even more materials than the ones that I wrote down here. And that brings us to the end of the winter quiz. You can check out more about Discover Materials at all of these different links. But for now, I've been Dr. Anna Ploszajski, material scientist. Thanks for joining me, and I wish you a very happy festive season.